Student at home, you are welcome to yet another edition of our program, Teaching and Learning on Radio. This time we shall be taking you on basic technology. And our instructor this time is going to be Mr. S.B. Yusuf.
Hello, well, good afternoon, my students, my fellow students at home. I am here to take the basic principles of transmission of low and high electricity under basic technology. It is important that
ai ka kai shi kasa yi
Na ɗauka ko zai
ba zai fito maka ba ya fi muna
dan na kaman ka kai sama za ka fi samu
zai kwashi iska ne
Can you loud?
loud
The way you speak in
good day, my fellow students. I am here to take basic technology. And the topic is basic principles of transmission of low and high frequency electricity. It is common that electricity is used everywhere now. So you want to wonder how does that electricity get to your house. Electricity has a lot of processes, and that is what we are going to discuss. The first thing is the electricity is coming straight from the generating station. From the generating station, there are two ways in which the electricity will come in. It's either you use underground cables. Underground cables are cables buried on the floor, or you use overhead cables. Overhead cables are cables buried on the top. When this electricity is generated from the generating station, it has to go through some processes, and that process is what we call the components of transmission system. These components are extremely important. Without this component, there is no way you will get electricity in your house. The first component is the generator. The second component is the circuit breaker. The third component is the substation. The fourth component is the transformer. The fifth component is the line support, and the sixth component is the insulators. I will now take the components one by one. Generator. The amount of electrical energy generated from generating stations are very high. So you need a very big generator of 11 kVA size. What do we mean by 11 kVA? Is 11 km per hour or 33 kVA line. In Nigeria, most cases, this is the type of line we use, 11 kVA or 33 kVA line. If you live in urban centers, even if you live in rural areas, if you go on the main road, you will see two lines across the road. You will see two lines across the road. The first line is an 11 kVA line. The second line is 33 kVA line. These are the lines from the generating station. So this line from generating station first would now go through the circuit breaker. What is the circuit breaker? The circuit breaker is a fault detector, where if there is fault from that generating station, it will break off. If there is fault on that line, the circuit breaker will trip off. So you find that out, you don't get light. The light is not transmitted again because there are faults there. That's the function of the circuit breaker. It is from the circuit breaker you go to the substation. What is a substation? A substation is a combination of so many power transformers where they retain this high voltage that is coming from generating plant. We have a primary substation, we have secondary substation. What determines whether it's primary or secondary is the amount of voltage that is going there. So you might be passing and you see a place they call substation and you see that it's a very small component. And you go to another place and you see that the substation is very large. It depends on the type of voltage that is being pushed out from the generating station to the substation. So the function of the substation is that it will withhold the electrical energy coming from generator for some time before the distribution continues. The next thing is the transformer. The transformer has two types. We have what we call the step up, we have what we call the step down. This depending on what you want it to do. The job of the transformer is either it steps up the voltage or it brings the voltage down. Now, from the substation it goes to the transformer. Then we go from the transformer, we have what we call line support. The line supports are towers and pole. I mentioned towers and pole. Towers are used as line support if the voltages are very high. Towers are used if the voltages are high because they are very tall. Then the other supports are poles, and there are two types of pole. We have the high tension pole, we have the low tension pole. It is these two poles, these are the line supports that are used to pass the electricity. Then we have what we call insulators. These insulators are mounted on top of the line support. The essence of insulation is for us not to have partial contacts. Sometimes we call something a surge. A surge is a process where two of the lines meet and is not separated. If such surge happens, what happens is either the GMP of the transformer goes off, the neutral drops, or the system will need to fail, or there will be a face-off. What we mean by a face-off is that one of the faces of the transformer will just go up if there is a surge. So for us not to have a surge, it is better you put an insulator. And these insulators are of three types. We have what we call the pin, we have the sachet, and we have what's it called? We have the suspension type. We have the suspension type of insulation. So in a nutshell, what we are saying is, what I'm trying to explain to you is, if from the generating station the light is generated, it will first go to generator. It is from that generator it moves to the circuit breaker. The circuit breaker is always attached on post, then it goes to the substation. From the substation it will move to the transformer. These transformers are what you see in your own areas, because you will see the line. If you live in a modern community or even in the villages where you have electricity, just take a step outside your house, and if you have a transformer there, you will see a concrete pole carrying 3 wires. Then under that 3 poles, you will now see another one of 4 being dropped exactly down there to the transformer. The essence of that is that the one carrying 3 wires will go to the transformer. It is the ones now that are coming for 4 that will come out from the transformer. That means that the voltage has been stepped down. What I mean by that is, I explained to you that generator is 11 kVA. 11 kVA is 11,000. And I can bet you there is no appliances in Nigeria that use 11,000. So even if you take it down, the transformers that you are going to use depends on the site. All transformers has rating. All transformers has rating. It's either you have 300,000 watt, 300 volts, 300 kVA, you have 500 kVA, and you might have 1000 kVA. If you look at this and this, it is far more beyond. So it means that the transformer, the light must be, the electric current must be stepped down before it's being used in the house. If you plug what we are using here, we will put a tester, you find out that it is Nigerian lighting system is about 200 to 240 volts per frequency at 50 hours. That's what we generate, and that is what we expect to happen to get at home. Naturally, I said low voltage and high frequency. Sometimes there are fluctuations from the generating station. We know that in Nigeria, most of our sources of electricity is water. And because of our own weather, during dry season, the water level will drop. And when the water level drops, the turbines will not function at 100%. As such circumstances, the amount of electric current generated at that period cannot be as high as that of the the rainy season in this part. But the other part where they use gas and they use turbine, they use the thermal turbines, their electricity and that. Because of this fluctuation, the voltage are always affected. Electric currents are generated with voltage. I want you, my student, to take an example so that you can understand better what I'm talking about. Take a bucket of water in your house, throw a stone inside it. What will you see? I will help you to answer the question. What you see is ripples. Those ripples form ripples. It is what you see is ripples. The ripples are the ones that forms the semicircle. They are, when you cut it, it will form a semicircle. This is the way the turbine works that generates electricity. It is from the ripples that there. So when you see the ripples, the essence of the ripples is to tell you that there's a sound. When you drop the stone inside the bucket, you will hear tom. Even if it's a waterlogged area, you drop the stone, you hear tom. That tom shows that there is what? there is a sound. And when there is sound, there is frequency. So it means that this electricity is generated with a frequency. So from the generating station, the frequency follows it down. Don't be scared. When you are traveling and you see tower, you start hearing the own sound follows it because it comes from the generating station. The only place where the own sound stops is at the transformer level. Because at that transformer, it has been brought to a case where the frequency is very low. The frequency is very low that you transmit straight to your house and you use electricity. So these are the basic concepts of high frequency and low frequency method of generating electricity. I want to recapture what I have said. First, I define how electricity is being transmitted with underground and high voltage overhead cables. The second thing is the component in the transmission system. The first component is the generator. It's either it is 11 kV generator or 33 kV generator. The second component is circuit breakers. The third component is substation. And I said the substation depends on the amount of voltage that is coming from the generating house. It will be primary when the voltage is low. It will be secondary when the voltage is low, high. Then the other thing is the transformer. I said the transformer has two types. It's either a step up or step down. The other thing is the line support. I said line supports are means of getting the light to your house. What we call line supports are poles, and the poles are towers. We have high tension, we have low tension. Then we have insulator. Insulators, the job of insulator is to make sure that there are no surge on the line support. They protect the line support from having surge. Those are the discussions I have. Now, I have an assignment for you, my students. The first thing is, we've been taught material science at this level. So I want you to please help me look for the materials used for this line support. That means materials used for high tension pole, materials used for low tension pole, and materials used for tower. The second question is this insulator. What are the materials used for the pin insulator? What type of material is used for the suspension type insulator? What type of material is used for the screen insulator? I hope I have enjoyed my class. If you have more questions, you can follow us on this WhatsApp group 090-2928-2040. The discussion continues from there. Thank you very much.
We hope you enjoyed the program. Join us next time as we bring to your way yet another edition of our program on teaching and learning on radio.